Now? No? Can you hear? Yes, okay, it's on. Great. Okay. Well, thank you, Danielle, for inviting me to come and talk to you all about Great Lakes water issues. I am new to BGSU and also new to Bowling Green. I was a professor at the University of Louisville for 17 years and just started my position at BGSU January 1st. So I've been here about 5 months, though my family moved here in the fall. So I have kids in school here. I came to Bowling Green for this position as the new director for the Center for Great Lakes and Watershed Studies, which is a relatively new group of faculty and students at BGSU. And I'll talk a little bit about what we're doing as a group to work on Great Lakes issues. But my plan for today is basically give an overview of why the Great Lakes are important, what are some of the current threats to our Great Lakes, and then what BGSU faculty and students are doing to address some of the problems in the Great Lakes region. And I'll just say that I took this job because I really love the Great Lakes. I have worked in Great Lakes systems for over 20 years. So I did I got a bachelor's degree at Denison University here in Ohio. And then I did my Ph.D. at Michigan State University and did a lot of work there in agricultural systems, prairie restoration. And then for the past 20 years, I've been doing coastal restoration, sand dune restoration work in Michigan. And so I'm happy to be closer to my field sites here in Bowling Green, and also working with just some really great people at the university who care a lot about Great Lakes health, Great Lakes water quality. So I'm learning a lot, and also just really glad to be a part of a great collaborative community here. Okay. See if I can get this to work. Maybe. It was just working. There it goes. Maybe. Okay, jump ahead. All right. Okay. So, this first part is maybe not new information for some of you, maybe new information for others of you, but our Great Lakes in North America are a really unique system. Our Great Lakes hold 90% of the surface freshwater in North America and has a lot of importance in terms of economic, ecological, and cultural significance. And so I could spend the next 10 minutes kind of lecturing you on what those key roles are, but I thought it would be more fun to have a little like mini trivia session. And so I have 7 questions, kind of trivia questions. And so what we'll go through some questions. And then maybe at the table, you can discuss what your answer is. And then on the honor system, keep track of your score, and I have prizes at the end of this little kind of mini trivia session. So again, 7 questions. We'll kind of work through to highlight the roles that the Great Lakes plays in our region. All right, so we'll start first with drinking water, right? So this is a photo of the Toledo water intake, right? Toledo depends on Lake Erie for its drinking water. So what do you think? So what % of Ohioans depend on Lake Erie for drinking water? All right, so maybe talk at your table, decide on an answer in your group. 2%, 10%, 25%, or 50%.
I have no idea.
25, 50. All right. So the correct answer is 25%. Lake Erie supplies drinking water for 11 million people, including 3 million people in Ohio. And so remember that lots of other people, including Canadians, depend on Lake Erie for drinking water. All right, so 25% of Ohio. All right, the Great Lakes are also really important for tourism, right? So it's a $17 billion industry. In Ohio, we get about 11 million visitors for Great Lakes activities annually. So fishing is obviously a really important aspect of tourism in Lake Erie. So the question here is, what do you think visitors to Lake Erie spend the most money on, right? Is it lodging, retail, food and beverage, or recreation? There are a lot of skiing, food and beverage. Ideas.
Hey, logic. Recreation.
So it's actually retail, all right? So these are data from Lake Erie Shores and Islands, and so this was in 2019, I think, but in 2019, 31% of the dollars were on retail. So I guess buying souvenirs or equipment or clothes, I don't know. But yeah, retail is the largest dollar amount. All right, culture and spirituality. So the Great Lakes hold really important spiritual and cultural significance for indigenous groups in our region, as well as many other people. This is a stamp, a Canadian stamp, honoring Josephine Mandamin, who was a Canadian and Anishinaabe elder, who was a co-founder of the Mother Earth Water Walk movement, and she actually led multiple walking trips around each of the Great Lakes in the 2000s, 2010s. She recently passed away, but was an activist for water protection, honoring our water, honoring the Great Lakes. So trivia here. Whoops. So thinking about Lake Erie, what does the word Erie mean in Iroquois? Iroquois language. Is it great water, Heron, beautiful water, or long tail?
Beautiful water.
Beautiful water.
Great water.
Great water. All right. Long tail. All right, the name Erie is derived from an Iroquois word that means long tail, which is a reference to mountain lions that live in our region in Pennsylvania area. I think Michigan means great water and Ontario means it's sort of related to beautiful water. All right, agriculture, right? So Great Lakes region has very high agricultural productivity. So it's responsible for 7% of all agricultural production in the United States, but it's responsible for 25% of all agricultural production in Canada. Oops. Oops, I can give away the answer. All right, so the question was, what crop has the most land cover in the Maumee River watershed, which is one of the most productive watersheds in terms of agriculture in the Great Lakes region? So corn, soybeans, wheat, or alfalfa. You saw the answer. Corn, soybean. All right, it is soybeans. So soy makes up 35% of the land cover in the Maumee Rivershed. So this is the map from an article that was looking at land cover, and everything that's green there is soybean cover, right? The soybean makes up the majority, but corn is second, and then wheat and alfalfa are third and fourth, respectively. All right, industrial facilities. So Great Lakes water is really important for industry in our region. It's critical for cooling factories, cooling power plants, cooling data centers, for cleaning, and also for product formulation, right? So this is one of the nuclear power plants along Lake Erie. So the question here is, what is the biggest current use of water withdrawn from the Great Lakes, right, in terms of volume? Is it for drinking water? Is it for data centers, manufacturing, or electricity production?
Or what should it be?
All right, here's some, a little bit of everything, so. For answer here is electricity. So, this is a graph from the Great Lakes Commission showing that almost 2/3 of the water withdrawn from the Great Lakes goes towards cooling power plants right now. Transportation, right? So we can't think of the Great Lakes without thinking of cargo ships, right? Great Lakes shipping lanes provide access to global markets for about 200 million tons of cargo yearly. All right, so here, what cargo type contributes the most tonnage processed through the Toledo Harbor? Is it coal, iron ore, limestone, or petroleum?
Limestone.
Limestone. All right. Harry, it was iron ore, right? So here, this, you can kind of see this graph here, right? So this is Toledo, this is Sandusky and Lorain. So Toledo, mostly iron ore, and then coal is second. But Sandusky is almost 100% coal, processing coal through the Sandusky Harbor. All right, and then biodiversity, right? So the Great Lakes region includes over 200 globally rare plants and animals and more than 40 species that are only found in the Great Lakes region, right? Nowhere else on Earth. And 2 of those species are lake sturgeon, right? So this very large fish that's only found in the Great Lakes. And then this is a picture of pitcher's thistle, which is a federally threatened species that is also only found in Great Lakes sand dune systems, mostly on Lake Michigan. And it's also a plant that I've worked southwest in the past. All right, so for this, how many species of fish live in Lake Erie? About 25, about 50, about 100, or about 200?
I would say 25, but.
All right, 100 right? That Lake Erie is home to 107 species of fish.
Yeah.
It's the most biologically diverse of all of the Great Lakes. And of those, 90 are native and 17 are introduced. So Lake Erie is a fish diversity hotspot. All right. Okay, so did anybody get all of the questions right? Did anybody get 6 of the 7 right? Okay, all right, okay. Your table wins then. Oh, prizes. Oh. The series. All right, I have some Freddie and Frida pins, so you'll also share those, all right? Okay. All right, so I think that this hopefully shows how important the Great Lakes are for lots of reasons. So now I'm going to move and talk about some of the key challenges that our Great Lakes are facing, right? And so I show here probably the #1 challenge that you all are aware of, and that's toxic algal blooms or harmful algal blooms. But I'm going to talk about a few others as well. All right, so harmful algal blooms, also called HABs, are really a problem in the western basin of Lake Erie. So in this map here of Lake Erie, so the western basin here is very shallow. It's the shallowest part of Lake Erie, and so it's most susceptible to these harmful algal blooms. The central basin has some problems with hypoxia, or lack of oxygen. So this is similar to like what the Gulf of Mexico experiences with those dead zones. We can get dead zones in Lake Erie in that central basin. And then the eastern basin is mostly okay, mostly because it's a lot deeper than the other parts of Lake Erie. All right, but we're all aware of harmful algal blooms because of the implications it has for our drinking water. Right, so harmful algal blooms are caused by high nutrient inputs, especially phosphorus and nitrogen. Cyanobacteria are the organisms that are responsible for these harmful algal blooms. They're also called blue-green algae, and they release liver and neurotoxins like microcystins and saxitoxins that harm humans and animals. Obviously here, the most notable harmful algal bloom led to the 2014 Toledo water crisis, where the city of Toledo did not have drinking water for 3 days, I think. Were people here, who was here for the Toledo? Yeah, right. So I'm sure you all have some good stories or interesting stories about that time. And so besides being a threat to our drinking water, and also we have better ways of treating water now to manage for the toxins that are produced, but it is still pretty expensive to treat water, and it also is a huge harm for tourism, right? Nobody wants to come to Lake Erie if it's going to poison you. Oh my God. Oh, quick. Oh. Yes. Yeah. What slide is that? Whoa. Oh, I'm not doing anything. I don't like doing that. Being temperamental. Oh my God. Why is it so good? Sorry, technical difficulties. Okay, so I don't have a lot of words. All right, so some of you might be aware, but NOAA through the National Center for Coastal Ocean Science releases an harmful algal bloom forecast every May. And so this was just released last week. So this is the Western Lake Erie early season forecast. For 2025, it's predicted that we will have a potential bloom severity in the range of 2.5 to 4.5, which is a mild to moderate, probably similar to last year. So you can see 2025, the projection right here. NOAA will come out with a more accurate projection in early June. And these projections are based on a lot of water chemistry data and climate data that they're getting during the spring in order to try to make predictions about what the algal bloom will look like in later summer and the fall. And so cities can use this information to make plans for how they're going to treat their water, where they're going to access their water, get the water from Lake Erie, and just generally prepare for, you know, whatever the situation might be later in the season. So just know that you can, every year, NOAA comes out with this projection forecast, and hopefully they will continue to do that. All right, so these algal blooms are really caused mainly by the agricultural activity in our area. All right, so fertilizer and manure runoff are the main contributions to harmful algal blooms. As you're maybe familiar with, so in our fields, we have tile drains that remove water from fields, move them to ditches, and then that water flows really straight to rivers and then Lake Erie, right? So all of the nutrients that are coming off of these fields basically go straight to Lake Erie. There are some other contributors to harmful algal blooms like urban runoff, but about 70 to 80% right now of the nutrients going into Lake Erie come from agricultural activities. There's also a lot of erosion problems, so soil losses. So there's the soil that comes off in heavy rain events that also goes straight to Lake Erie eventually. And this is what clogs our shipping lanes. And the Army Corps of Engineers spends millions and millions of dollars every year to dredge harbors throughout the Great Lakes to keep them open for shipping. And that is because of this runoff of soil and erosion. We're also facing changing climate conditions. So as we look to future climates, we can expect more extreme rainfall events, stronger storms, and this can lead to increased runoff from agricultural fields, especially in the spring. This is a map here showing what is predicted for the mid-century in terms of runoff changes in runoff volume from agricultural fields. So in our area, we can expect maybe a 10 to 15% increase in runoff just due to increased precipitation, stronger storm events over the next 25 years. We also know that droughts and warmer temperatures can exacerbate those harmful algal blooms and stress our water supplies. And so here's a graph just showing those predictions of temperature changes over time. The green is for a lower emissions scenario. Now what is more likely is this higher emission scenario, which is predicting about a 10-degree increase in average temperature over the next 50 to 100 years. And already we're seeing the effects of climate change. So those harmful algal blooms in Western Lake Erie now last about a month longer than they did in the 1990s because of changes in climate. Another challenge is emerging contaminants like microplastics. So microplastics are in the news a lot right now. These are very small pieces of plastic, smaller than 5 millimeters, that can come from pre-industrial or post-industrial sources. And so this picture here shows someone sieving plastics out of sand on a beach. A lot of these are actually bigger than what we would consider a microplastic, but microplastics, you can't see them with the naked eye, they're just very small. And this graph here shows the sources of microplastics in Lake Erie. And the number one kind of microplastic pollution we have in Lake Erie is fibers from clothing. All right, so if you think about see what your clothes are made of, if they're made of polyester or acrylic, then when you wash clothes, that water drains to our sewer system, that sewage makes its way to Lake Erie. Those fibers last a long time and can contribute to a lot of potential problems in our water. So for example, microplastics can starve fish. So if fish accidentally eat them and they sit in the guts of fish, they take up space and the fish can't eat enough real food to keep them healthy. They can also leach toxic chemicals. They can harbor pathogens. So they're basically just like floating little islands in the lake that bacteria can stick to. A lot of fish pathogens can stick to these microplastics. They can accumulate in fish muscle. So when we eat fish, we can incorporate it for consuming microplastics. And really interestingly, it can also interfere with photosynthesis. So it's been shown that microplastics So for example, if a farmer is irrigating with water from Lake Erie, then the microplastics can interfere with corn photosynthesis or and growth. There's a lot that we don't understand about microplastics including like long-term effects on human health. Currently, microplastics are unregulated and under-monitored. And so this is a big area for future research, just to try to understand what these plastics are doing to us and to our ecosystem. All right, another kind of emerging contaminant are novel chemicals. So you might have heard of PFAS or forever chemicals. These are chemicals that are used in firefighting, foams that are used to suppress fires. They're also used in creating like water repellent clothing. They're used to just used a lot in for fire retardants, fabrics, and these chemicals are called forever chemicals because they take forever to break down, right? So they're very resistant. They last a long time in our ecosystem. And there's a lot of interest in them now because they have been linked to a lot of human health issues, including increased cancer risk, developmental delays, reduced immune function, and hormone disruption. And this is true for humans as well as fish and other organisms that live in areas that can be contaminated with this PFAS. And this is a photo here of some of the foam that can be produced by these PFAS chemicals, and this is, I think, in Lake Michigan, actually. And then another type of chemical contamination includes a lot of our pharmaceuticals. So we actually have researchers at BGSU who have shown that there's a lot of pharmaceuticals in our waterways, including caffeine, Benadryl, antidepressants, and opiates. So they've all been found in very common to be very common in our waterways in this area. And for the most part, we don't know what the long-term effects of that is, right? Of low levels of these pharmaceuticals in our water supply. Additionally, we lack information, but it can also be very difficult to treat drinking water for PFAS and these pharmaceutical contaminants. And then finally, invasive species, right? So we have a number of animals and plants that are not native or not originally from the Great Lakes region who have been introduced on accident or sometimes on purpose, and that have really significant ecological impacts. We have a lot of non-native species in the Great Lakes, so over 180 aquatic non-native species. Most of them just hang out and don't bother anybody, but there are about 13 that have caused really significant ecological and economic impacts. What's tricky is that we can't necessarily predict what not native species will become problems later on. So this is just a list of the top 4 problematic species, animal species in the Great Lakes. So zebra mussels and quagga mussels, if you've been to Lake Erie, any of the Great Lakes or any water body, inland water body, these are very abundant. They cause biofouling, so they just cover boat motors, gears, anything that's stationary they will attach to. And they can selectively feed on the beneficial algae in lakes, leaving that harmful algae to basically without a competitor, so it can kind of thrive. Grass carp are very large fish in Lake Erie. They can consume vegetation. They reduce commercial fish spawning grounds. They can host novel fish parasites, and they alter predator-prey interactions. And there's a lot of interest right now in managing grass carp and also other related carp, so we have them in Lake Erie, but common carp are not in much abundance in Lake Michigan right now. So there's in the news, there's some federal dollars being spent to try to keep these carp species out of the Great Lakes as much as possible. Sea lamprey are found in all of the Great Lakes. These are parasites that can feed on sport fish and can cause declines in sport fish populations. And then round goby are actually a really small fish that they can compete with native fish for food. and territory, but they also eat native fish eggs. And so that's why they are a big problem in Lake Erie. And then just a few invasive plants, because I'm a plant biologist by training. So one that I'm sure you're familiar with is common reed or Phragmites, and it's everywhere on the interstates and probably every wetland that is not managed. Common reed can really alter wetland hydrology, how water moves through these wetlands. It impacts the recreational use of shorelines, and it increases fire risk because in the winter, it's basically, in the early spring, it's just a large amount of dead plant material that is highly flammable. Another problematic species is Japanese siltgrass, which can invade forests and wetlands and can suppress native plants and animals. And then water chestnut is a true aquatic plant where it can cover lakes, inland lakes, as well as Great Lakes. And this inhibits the growth of the beneficial algae and aquatic plants and can reduce water oxygen levels. All right. So in the last little bit of time, I just want to talk about that's all depressing, right? So we can let's try to get a little bit more positive. And so how can we work towards some solutions for these environmental threats? And so the group of researchers associated with the Center for Great Lakes and Watershed Studies are really trying to do that. Just a little background on our center. We're a pretty new center on campus, and we've existed in the current form for about 2 years. They had sort of an interim, a core group of faculty who have done research on Great Lakes issues for a long time, but then they decided to get together and form a more formal group to help with collaborative efforts. And so we're in our second year of basically a 3-year start time. And part of the initiative was hiring me as an external director to come in and help get the center off the ground, even though there's been a lot of research at BGSU related to the Great Lakes before I came. All right, so I'm going to refer to our center as CGLWS, Center for Great Lakes and Watershed Studies. So right now we have 21 faculty from 4 different units at BGSU, biology, chemistry, SEAS, which is the School for Environment and Earth Sciences, and then we just got our first history professor, right? So he does work on environmental history of this region. And our mission is really to foster innovative, interdisciplinary scholarship in support of Great Lakes watershed health and public well-being. We've also been able to engage about 100 students in research, freshwater research, provided funding for their research and for travel to grants and things over the past 2 years. And we had our first annual meeting in February where we had about 50 people attend. So this is the faculty and students who are part of that first annual meeting. All right, and we use this tagline for our center that we try to use watershed scale thinking for watershed scale problems, where we're really trying to highlight the connections between the land, the lakes, and our lives, right? So if you're not familiar with the term watershed, this is basically just the area of land, a given area of land that drains into a given water body, right? So in this cartoon here, this little shared water body, natural areas or agricultural or urban areas, all of the water drains into this shared water body. So we are in the Maumee River watershed, but also the Lake Erie watershed because the Maumee River goes into Lake Erie. And I know this really well because I commuted from Louisville to Bowling Green weekly last fall, and on 75, and I passed this entering the Lake Erie watershed sign once a week. So it's good that we're aware of where we are in the land, on the landscape, right? So here's Bowling Green, we're in this Lake Erie watershed. Here are the other, the land for the other watersheds for the other Great Lakes. Okay, so what are some of the things that our group is doing right now? Okay, so we have several faculty and students who are involved with the project called H2O Ohio. Can you raise your hand if you've heard of H2O Ohio? Okay, just a few of you. All right, so this is a really big water quality initiative that was started in 2019 by Governor DeWine. He's invested about $270 million statewide in mostly focused on wetlands creation and monitoring to improve water quality, mostly Lake Erie water quality. All right, there's also some money in this program that goes to helping farmers better manage nutrients on their land and to try some more novel agricultural practices. And so BGSU researchers have been really involved with H2O Ohio by monitoring water chemistry, hydrology, and vegetation in wetlands in Northwest Ohio. And so some key findings from this work is that we've been able to show that plants use nutrients at different rates, which can affect the recommendations we can make to for new wetlands in terms of what plants to use. And then also researchers have been able to show that wetlands only work if we remove nutrients. They only work to remove nutrients if they're hydrologically connected to other wetlands. So you can't necessarily just go in your backyard and dig a new wetland. It needs to, you need to make sure it's connected to other wetlands in order to really function as they are intended in terms of nutrients. Okay. We're also doing a lot of monitoring of harmful algal blooms. So BGSU researchers are monitoring algae in the Sandusky Bay in that region. We have other researchers who are working to identify novel toxins and the genetics of toxic algae. We also have faculty who are doing research globally on harmful algal blooms, for example, in Lake Victoria in Africa, in Florida, and in the Great Salt Lake, right? So trying to make some comparisons between what we know about harmful algal blooms in the Great Lakes and what is going on in other parts of the world with algal blooms. And we are responsible for two buoys, but one is the Sandusky Bay Bridge buoy, which is part of NOAA's Great Lakes observing system, or GLOS. So all of these dots on this map here represent different buoys that are deployed by NOAA that monitor water chemistry, temperature, precipitation, and other things to try. And all of this information is what is used by NOAA to make that like algal bloom forecast, right? We also have a boat that lives in Sandusky Bay called the RV Ziggy, or Research Festival Ziggy. This goes out once a week to collect water samples during the summer and fall months. So what we've been able to show here is that harmful algal blooms are more common due to climate change, that farmers should start managing for nitrogen as well as phosphorus. And then there was some work to show that there was a dam removal project on the Sandusky River, and the removal of that dam it really helped to improve Sandusky Bay water quality. All right, we also have a group of researchers who are really interested in agriculture and agricultural solutions. And so one project is exploring the use of harbor dredge as a soil amendment. So like I said before, so the Toledo Harbor is actively dredged yearly by the Army Corps of Engineers. And in fact, Toledo Harbor has more sediment dredged than any other port on the Great Lakes. Right, so the Toledo Harbor alone accounts for 25% of all the dredge activity in the Great Lakes region. And is the equivalent of about 27,000 dump truck loads of sediment removed from the shipping lanes annually, right? So taken from the water and pulled up on land. It used to be that these dredging barges would dredge the sediment from the bottom of the lake and then go out to open water in Lake Erie and then dump it off, right? And that's just resuspended all of the nutrients that were in that sediment and was contributing to the algal blooms that were happening, right? So now the Army Corps has to bring all of that material from the bottom of the lake and do something with it on the land. Right now, it's mostly being stored at the Port of Toledo. There's some big storage facilities there. That is not a long-term solution, right? And so the Army Corps is really interested in trying to come up with alternate uses for this. And so we have researchers who are looking at the use of dredge materials to improve agricultural soils and aid in wetland restoration. So basically taking the dredge sediment, removing the water from it, and then trucking it out to a farm field and applying it to a field. And this is really restoring the soil cycle, right? So the soil came off the field in the first place, went into the lake, and now we're trying to return it back to the fields. And so one notable finding is that these dredge materials do seem to improve crop and soil health in both greenhouse and field settings. So it's just a matter of whether this can be scaled up from kind of research scale to real life usefulness for farmers. We're also doing a lot with fisheries management. So we have a group of researchers associated with the Aquatic Ecology and Fisheries Lab at BGSU, who's working with Ottawa National Wildlife Refuge and also Old Woman Creek National Estuary to look at habitat restoration in wetlands. So reconnecting wetlands. This is a picture from Ottawa National Wildlife Refuge where they're installing these big tunnels to connect wetlands. This is the top of a tunnel. This is what is actually underground there in order to help fish move between wetlands. And what we found is that reconnecting wetlands improves sport fish migration to Lake Erie, and restoring vegetation to rivers will improve water quality and sport fish abundance. We also have a group of people doing aquaponics research, right? So aquaponics is basically a combination of aquaculture, right? So raising fish for food, and hydroponics, so raising vegetable crops, soilless with just based on water. And so this is a way of connecting fish production with vegetable crop production. And well, oops, oh my gosh, why did you do that? It's so weird.
You're pressing the side.
Huh?
You're pressing the side.
I'm pressing the side button. Oh, I'm sorry. I'm almost done. Okay. All right, so notable findings here. So yellow perch that were produced with aquaponics systems at BGSU are comparable to wild caught and farmed fish in taste and nutrition, while also providing the added environmental benefits of like keeping the nutrients in this closed loop system. And you can find out more about this. Has anybody ever seen the PBS show America the Bountiful? All right, it's on PBS. They're in their second season, and they in April just released an episode that's called Walleye in Ohio, and it has about a 5-minute clip that is BGSU researchers talking about their aquaponics work. So go to PBS, try to find this America the Bountiful. All right, and then finally, this is not quite Lake Erie related, but it's some of my work, so I just wanted to throw it in, right? So we're also doing some work with coastal management in terms of sand dune restoration. So the Great Lakes sand dunes are the most extensive freshwater dunes in the world, and they provide habitat, shoreline stability, and recreation. This is a map of where sand dunes are found throughout the Great Lakes. The largest extent is here on that eastern shore of Lake Michigan, and that's where I've done a lot of work. Threats to these habitats include housing development, invasive species, and climate change. I've done a lot of work looking at this dune grass and how it functions in these sand dunes. And so some of the work I've done over the past 15 years or so has shown that there are some beneficial fungi that can live in both the roots and the leaves of plants that can help them in sand dune restoration efforts. And so this was a picture of a project I had for a long time up at Leelanau State Park in Michigan, which is like north of Traverse City area. And this is the picture. This is a plant roots, and these are fungi that are attached to the roots. And so what I'm interested in is how these fungi can really help the plants survive in this really harsh system. All right, and then just to wrap things up, where are we going next? So they said we're a pretty new center. So we have 3 main goals moving forward. First, we're hoping to increase our internal collaboration network and member involvement. So ultimately, I really view us as an interdisciplinary center, multidisciplinary center, and I would love to incorporate more arts and humanities scholarship focused on Great Lakes water issues in the future. We're trying to develop interdisciplinary education, scholarship, and outreach opportunities. And we're trying to pursue diverse funding opportunities to sustain and expand our activities. So we're recruiting faculty and students from other units. We're supporting interdisciplinary initiatives across campus, like there's a new water resources minor for undergraduates that's going to be coming out in the fall. We're working on collaborative grant writing, trying to make connections with government, industry, and nonprofits in the area, and then engaging with community and alumni partners. So if any of you have any suggestions or connections to make, please do let me know. All right. With that, I'll just take any questions you might have. Here's my contact information if you do want to reach out at all. And then I will say just a little plug, you know, if you're motivated or if you have anybody who might be motivated to donate to our center, we are able to take donations to help support our mission to do this interdisciplinary work on Great Lakes water issues. So thank you. Yes.
You mentioned